Hello students, how are you? Okay, let's start the chapter waves. What do you mean by waves? First of all, you should know what is wave motion. What do you mean by wave motion? It is a kind of disturbance which travels through a medium due to the repeated vibrations of the particles of the medium about their mean positions. The disturbance being hanged over from one particle to the next. In the wave, both information and energy propagated from one point to another, but there is no motion of matter as a whole through a medium. I am repeating once again. It is a kind of disturbance which travels through a medium due to the repeated vibrations of the particles of the medium about their mean positions. The disturbance being hanged over from one particle to the next. In a wave, both information and energy propagate from one point to another, but there is no motion of matter as a whole through a medium. Three basic types of waves. There are three types of waves. First is mechanical wave. Mechanical wave. The waves which require a medium for their propagation are called mechanical waves or elastic waves. For their propagation, the medium must possess the properties of inertia and elasticity. For example, water waves, sound waves. Electromagnetic waves. The waves which travel in the form of oscillating electrical and magnetic fields are called electromagnetic waves. Such waves do not require any material medium of their propagation. For example, visible light, radio waves are electromagnetic waves. Now, next is matter waves. Third is matter waves. The waves associated with microscopic particles such as electrons, protons, neutrons, atoms, molecules, when they are in the motion, are called matter waves or de Broglie waves. Matter waves associated with fast moving electrons are used in electron microscope. Now I will talk about transverse wave. What are transverse waves? These are the waves in which the particles of the medium vibrate about their mean position in a direction perpendicular to the direction of propagation of the disturbance. These waves can propagate in those media which have a shear modulus of elasticity, such as solids. Longitudinal waves. What are longitudinal waves? These are the waves in which the particles of the medium vibrate about their mean position along the direction of propagation of the disturbance. Along the direction of propagation of the disturbance. These waves can propagate in those media having a bulk modulus of elasticity and are therefore possible in all media, solids, liquids, and gases. What is progressive wave? A wave that moves from one point of the medium to another is called progressive wave. Now I will talk about some specific definitions of the waves. First is amplitude. What is amplitude? Amplitude, and it is denoted by capital A. It is the maximum displacement suffered by the particle from the mean position during the propagation of the wave. It is the maximum displacement. Now time period, capital T. It is the time in which a particle of the medium completes one vibration about its mean position. It completes one vibration in one vibration. It is called time period. Frequency. It is the number of waves produced per second in a given medium. It is the number of waves per second. Wavelength lambda. It is the distance covered by the wave during the time of a particle of the medium completes one vibration about its mean position. It is the distance between the two nearest particles of the medium which are vibrating in the same phase. Angular wave number or propagation constant. Propagation constant. It is also called angular wave number. It represents the phase change per unit distance. It is equal to 2 pi upon lambda and it is denoted by k. SI unit of k is radian per meter. Now the wave velocity v, small v, wave velocity v. It is the distance traveled by a wave in 1 second. The relation between the wave velocity, frequency and wavelength. Wave velocity v, frequency nu and wavelength lambda. V equal to nu lambda. Relation between wave velocity, time period and wavelength. V equal to lambda upon t, or it can be written as omega upon k. K equal to 2 pi upon lambda. Velocity of transverse wave. Velocity of transverse waves. First is velocity of transverse wave in a solid of modulus of rigidity neta and density rho is given by v equal to neta upon rho. Velocity of transverse wave in a string of mass per unit length m and stretched under tension T given by v equal to under root T upon m. Velocity of longitudinal wave. Now I will talk about velocity of longitudinal waves. First is velocity of longitudinal waves in an extended solid. Extended solid means Earth's crust of bulk modulus K, modulus of rigidity neta and density rho is given by V equal to K plus 4 upon 3 neta upon rho. K plus 4 upon 3 neta is called elongation elasticity. Second is velocity of longitudinal waves in a long rod of Young's modulus y and density rho is given by nu v equal to y upon rho. Third is velocity of longitudinal waves in a liquid of bulk modulus k and density rho is given by v equal to k upon rho under root k upon rho. Number 4 is velocity of longitudinal waves in a gaseous medium of bulk modulus k and density rho is given by v equal to under root k upon rho. According to Newton's, when sound travels through a gas, the changes taking place in the medium are isothermal in nature. So Newton's formula for the speed of sound is given by v equal to k isolated medium upon under root k isolated medium upon rho equal to p upon rho, capital P upon rho. P is the pressure of the gas. According to Laplace, when sound travels in a gas, the changes taking place in the medium of the adiabatic. According to Laplace, when sound travels in a gas, the changes taking place in the medium will be adiabatic. So Laplace formula of the speed of sound is given by v equal to k adiabatic upon under root k adiabatic upon rho, or it can be written as under root gamma p upon rho. Gamma is Cp upon Cv and it is called specific heat ratio. Factors affecting the velocity of sound through gases. What factors will affect the sound in gases? Number 1 is effect of pressure. Pressure has no effect. Pressure has no effect on the speed of sound. Effect of density. V is directly proportional to 1 upon under root rho, or it can be written as V1 upon V2 equal to under root rho 2 upon rho 1. Effect of temperature. V equal to under root gamma RT upon M, or it can be written as V equal to under root T, or it can be written as V1 upon V2 equal to under root T1 upon T2. Temperature coefficient of velocity of sound is given by alpha equal to Vt minus V0 upon T. Effect of humidity. Sound travels faster in moist air. Effect of wind. Effect of wind. What is the effect of wind? If the wind blows with velocity w in a direction making an angle theta with the direction of sound, then the resultant velocity of sound will be given by v dash equal to v plus w cos theta.